here we go. We're going to look at some of our icons. My toolbar won't pop up. Y'all see MotoSim? There we go. So this little guy right here, can you see it? It says show programming pendant. So here's our teach pin. What four ways can we jog the robot? What's that? Yeah, no, we don't. There's no such thing. You can go over there all day long and look at that teach pin on there. You will not see a Cartesian. Okay, we got what? Okay, we can jog them, whirl. What else? Joint. There's no such thing as a linear jog. Starts with a T. Tool. The other one starts with a user. Right? So 4 ways we can jog the robot. Now, MotoSim calls joint. They call it link because you notice the robot axis, when you go down through there, they call them links. So if I wanted to do a joint jog, I would put it right there. But this, by the way, on the Motoman, they call their joints SLU-RBT. But they fall right down the line, right? So this would be joint 1, which is my what? Oh, I got it on each. Right here, right there, where it says show programming pendant. Okay. So what I'm going to do is I got it on joint. This is axis 1. You'll see it swinging around. I'm going to go slow.
I'm trying to see what you...
Right here.
Okay, that look like a calculator?
Yeah, but when you hover, when you do what they call a hover above something, what happens is this little text box pops up that shows you the function of the tools. So yeah, here's the one that looks kind of like the calculator, but I don't know how they could have drawn it. So here's axis 1 using joint jog, right? See that? Here's axis 2, which would be the shoulder. Here's axis 3, which would be the elbow. Here's axis 4, which is rotation around the 5 and 6. So it's just like you did over there. By the way, I'm hitting, but see, if you hold it down, it's going to jog, right? Or you can click on it just like over there and it does increments. This is fast speed if you really want to move it, but that's kind of, we're talking about real fast, right? And then, so here's where we set our speeds, medium, slow, in inch. Inch, it moves in very small increments. It takes you a real long line to see it. Okay, see that? Of course, this is rectangular. Now notice the keys changed to what? X, Y, Z. This is yaw, pitch, and roll. Okay. Let me take it off each so we can see it. Normally, we put it on slow or medium. Don't use fast. See, so there's pitch, right? Yeah, but we have the tool center point set now. So when we do roll, pitch, and yaw, since we have the tool center point set out there at the very tip of the wire, it's going to jog around that. Okay. Right? And then, of course, there's row. That's in what? Rectangular. They call it rectangular. That's what we learned is whirl or base, and tool is tool. Of course, now X is going to be around the tool, right? Y'all understand that? Or Z, these are going to be around the tool. These are going to be the same. But these right now are X, Y, Z relative to the tool center. Are we okay? Yes or no? Okay. So what's this? This is link is what we call joint. Rectangular is what we call whirl. Tool is tool, and user, we're not going to do a user frame. Are you okay? Okay. Now, when we program a move, so this is where you do it. It's a little bit different, but not much different than now on the actual robot. This is the move that it's going to use by default if you don't do what? Change it. So if I want a different move, right now I have a joint move. I have a velocity of 100%, and I have a position level of 7. Then we talk about position levels. Position level is the round off. So a position level of 0 would be, it would hit the point. That would be a fine move. A position level greater than 0 would be what we call a continuous move. So it means it won't stop at points, right? It'll cut corners. So when I click on this right here, can y'all see where I'm at? It says what? Move. This brings me up my moves. These are all the moves that's available to the Motorman robot. It has the move J would be the what? Joint move. Move L would be the linear move. And move C would be the circular move. And then they have what they call a spline move, which we're not going to get into. Circular.
Oh, circular.
Which some of y'all didn't get into, but y'all gonna, because of the class. This is where we set the position level. So normally in this class, if we wanted to hit the point, we'll use what? Okay, if we want it to round off, then we're going to play around with it until it follows what we want, right? That makes sense? Now, what you want to do, once you got your, and of course, now I got a joint move, okay, then what do I want to do with this move? Well, I want to add it to my program. So look down at the bottom, it's got 3 options that I can do. What are they? Okay, so what would I click on? Add, and then I'd hit what? So as it catches up with me, I hit enter, and it'll pop that move in down below the move that I just did. And now when I do my program, by the way, single step, the way we single step it, we just put it on any move we want to. Robot moves to that. We use our cursor control keys on the numeric keypad, right? The cursor control, I mean, between the main keyboard and the numeric control, the cursor control, the arrows, and I would just step it down. And this is the way we single step, which is really neat because you can go forward, backwards, any way you want to. So here's my first point I taught. This is my second point I taught. And this is what I'm working on. And this is the point that we just talked about. Okay? I don't like that point. What do I need to do? Okay, so what would I do? Put it on the point you want to get rid of. Hit on delete and do what? Enter. Okay. And then it's what? Gone. If I don't like, if I want to reteach it, I would do what? I'd hit modify. But I was at that point already. And what did it do? It did a touch up, right? Everybody okay? That makes sense. Pretty simple, right? A lot like the robot you were on. Okay. Now this is some stuff that they add by a computer. It's positioning. So notice right here on your teach pin that you got position. Now by default, it's going to bring it up to pulse, which we don't use. So right now the robot's at 0. This robot is at its home or its origin position. What I know, because everything here is what? 0. But watch what happens. I'm going to come over here. I'm going to put it on base. Now this is where it's at relative to the Cartesian system. So if I wanted to go down 15 millimeters, then I would come up here and I would subtract 15 millimeters from that. Now by default, your step size is 10. So notice when I come up here and hit this, it moved 10 millimeters, right? See that? But this is, so what we're saying here, if I know where it's at and I want to go down 100 millimeters, all I got to do is come over and click on that sucker 10 times. And that's what. If I wanted to go, now I'm going to go to my step size and look at our step size. So I could go all the way down to 1 millimeter per step, right? See that? Or I could key in the value. I mean, so if I come over here and I say, okay, I'm setting at 164, I want to go down 10, then I would come over here and I'd say, well, it's actually setting at 155. I'd come up here and say what? I go 155, and then I just did tab, and it moves to that position. So what we're saying is you don't even have to jog the robot. If you know where you want to go and you know where it's at, you can just key in the values and send the robot up 15 or down 15 or over 15. Does that make sense? Pretty neat, right? This is another unique feature. Once we have the tool center point set, then we can jog the robot to any place we want to. So they call it OPL. I used to remember what it stands for. But what I'm doing is I'm going to say I'm going to move to a model and I'm going to go to a box. So I want to go to a corner. So I'm going to the vertex of that and then I'm going to pick a model. Now watch this. I'm going to come over here right close to that right there and I'm going to click on it. And what did the robot do? It went to that exact vertex of that corner. If I wanted to go here, I click there. If I want to go there, I click there. If I want it to come down here, I click there. If I want to come over here, I click there. That makes sense? Let's say I want to do a well right in the corner right here, right there. I click right there, it comes to there. And I want to raise this thing up. I want to raise it back up, straight back, and I want to come back 15 millimeters. What would I do? Well, I'm going to come back here and I'm going to put it on a tool jog. And then I'm going to come over here and I'm going to go to inch because we're going to go back. I'm going to look at this Z right here. What's Z at? Okay, so what would I want to go positive 15 because it's negative. So I want to subtract 15 from this. What would it give me?
Negative
105. Okay, so I'm going to come over here. I'm going to put this on inch. I'm going to come over to Z right here. I'm going to hit minus. And I'm going to come up to that till it says negative 105. That's 15. That's 15 millimeters. By the way, this is 14.999. So that's 105 millimeters, right? So now I could teach that point. Ain't that neat? I mean, now it's perfect. I mean, it's as perfect as your models are. And of course, so it's very important that you make models. But you can go anywhere. You can set up OLP to go to the center of something. So if I come over and do that and take off vertex. Then I come up here and teach that. It went to the center of the top right there. So it's right in the very center. I mean, it is in the center. Huh? Base we go because pulse means nothing. That is the actual encoders. What does that mean right there? So this, relative to the encoder, it's setting at count number 29,035. I don't care about that. What I'm concerned with is a direction, X, Y, Z, Cartesian. Because now I know this is Z, right? This is Y, and this is X. So if I come over here and put it on base, now this is the number relative to this frame right here. So if I could get that tool center point to that exact point right there, it would be X, Y, and Z would be 0. Row, pitch, and yaw might be a little different. So that means Z, this Z is 79 up above that right there. That makes sense. Okay, or where zero's at. So let's take it to 0 and see exactly where zero's at. But what we're saying is that once we get this thing to measure for us, I've got it in center. Then it don't make any difference what the numbers are, but these are millimeters, right? You understand that? And all we have to do now is just move it back from where we measure it back up. Does that make sense, Kathy? You understand what I'm saying? So I can go to the edge. I can go free. So if I go free, we can just click it around anywhere on here. See there? And it goes wherever I point to, that's where it will go to. But usually when we do wells or something, we're going to start it at a vertex, right? Or we're going to start it in the center. But if I can't even do that, I can do free. And if the robot can get to it, it'll get to it. If I come up here and tell it someplace, it's going to come up and says, it can't get there, right? Because if I punch right there, it did get there. But now it can't reach that point. But when we use that free option, I mean, if I can point that little pointer where I want it to go to, then that's what it's going to do what? So vertex, y'all know what the vertex is? Edge would find the actual edge of it, okay? Vertex sends it to the exact corner of a square, right? Center sends it to the what? Exact center. So I've clicked in here somewhere, so that is the exact center of that guy right there. And that OPL is really, really neat because it makes us really get exact position. Not very hard to do, right? So how do I do that? Just come over here and say what? OLP. And sometimes this box right here is not checked. If it's unchecked, it means it won't work. So you need to make sure this box right here is what? Check. If you close it, it automatically turns it off. Everybody okay? Make sense? By the way, if you're not going to change things and you want to be able to read, if you go to long, notice what it does. It shows you the whole command. And you can always go back to what? Short. Are you okay? So teaching points, very, very easy with this. Being exactly accurate is very, very easy with this. But by the way, if you come over here and use these, you need to come in and go to this inch right here because it's going to move real fast, right? So you see when I was trying to make a measurement with this, I used this to make my measurement, but I moved it with this because I was trying to do a tool jog. If you came over here, if you move it with the X over here, so over here you can't change the orient. Let's see if we can. No. For some reason, once you set a tool center point, when you go over here, if you select tool, it won't let you do anything. So if I want to do a tool jog, I'm going to leave it on base, right? I'm going to select what? Tool jog over here. I'm going to come over here and put this on inch. And now I can come back and notice now it's jogging relative to the tool. So now it's coming back exactly relative to the tool center point. So what that means, if I wanted to come back here to this vertex right here. Now if I go back here and I do that on whirl, if I do it right here, Z's going to come straight up. But what I want to do is I want to come back 100 millimeters at the same. So usually when we come in on an approach angle, we go ahead and establish it out here and come straight in, right? Y'all understand what I'm saying? So what I would do is I want to break this back. I want to bring this back 100 millimeters. So what I would do is I would put that on tool. I would put this on what? Inch. And then I would come back and I would jog it right here. So now when I put minus Z, it's going to come straight back. But watch, it's jogging relative to the tool, right? See what I'm talking about? And then I could bring this up until it shows me 20, or as close as I can get. And now, as soon as I get this to 20, and that's going to be 100 millimeters from that right there. And this is what I want to do right here. I want 100 millimeters approach. So we're going to do ours a little different than the book. The book wants you to try to get it over here. So when you teach your job, first of all, you're going to teach your start position, right, with the robot back here. And then what you're going to have to do is you're going to have to swing it over. You're going to have to swing it over here. Let me go ahead and teach this point. I'm going to go down here. Sorry. And I'm going to teach this as a joint move. Position level 7. I want it to hit the spot, so I want it to do what? I'm going to change this to a what? 0. I'm going to say OK. I want to teach this spot. What am I going to do? Add. So I'm going to hit enter. Okay, it adds a spot. I'm going to put the robot back at that position right there. So this is my home position, or my start position. Then what you're going to do is you're going to have to move the robot out so it can clear the top of the thing, right? You understand that? If you do it the way the book teaches, the way the lab procedure is, they want you to bring it over here from over here, and it's going to go right through this guy right here. Okay? All right. Then what am I going to do? Then I'm going to bring it down to about 100 millimeter above the point. Okay? Yeah, usually what we do is and these are all joint moves. So if I run it, and you can actually see, since we're using 100%, since we're using round offs, can you see what it actually did? Okay. I know it's almost time to go. So this is the way we run the program, by the way. We can come up here. This will reset the program to the start. Can you see what it did? And then this will do what? This will run it or play it. And that's what I have so far. Can't remember. It's not even in the textbook. You'll just have to, what do you want it to make? It's not in the lab. By the way, another feature, just a little bit, we have a thing they call teacher, which is what we're going to do. when you set angles, so all these welds are supposed to be made at a precise angle. Well, the problem is, if I jogged it every time, I would have to reset the angle. So what Teacher does, it allows you to teach an angle. So when you use that OLP, if you have a teacher set up, not only will it go to that point, it'll also automatically set the torch or what your tool at the precise angle. And they call it Axis 6, by the way. We'll talk a little bit more about that. So that's what this frame is right here. This is what Teacher did for me. So Teacher allowed me to go in and key in this information right here. And then see, it's got the angle and everything on there. And now if I use OLP to move it over to that point, not only is it going to move to that point, it's going to also do what? Set the correct angle, which is important on welding. That's one thing a robot that can do that people has problems with. You know, when they weld, when they're doing the welding angle, it's always an approximation. But when you do it with a robot, your angles are going to be perfect, your speeds are going to be perfect. You know, so if you wanted to weld at a certain millimeters per second, then by George, if you set it at 100 millimeters per second, it's going to weld at that speed. I don't know what the lab says. We're going to do 2 approaches. We're going to do 2 approaches, and then we'll finally bring it into here. I think we'll do 2. I think we bring it over here and bring it down to something, and then come in real slow and bring it into the workpiece. I can't remember what the second approach is, but it's in y'all's lab. I'll look it up and go ahead and do the program for you, and then that way we'll let you see how it's supposed to look when y'all get through it. But y'all can see, so I've started this program from scratch. Man, you can understand why guys love simulations, because as far as getting your points and your accuracy and everything, you don't tear up nothing. We're going to use collision detection. I'll show y'all collision detection, which is really cool. So the robot, so I don't know, I can tell here it don't collide. But, you know, and what I like about the simulation, it actually puts this little screen up there that shows you the what? It shows you the path. So that's the path that tool center point set when it moved over to that point. Okay, guys, y'all have a good weekend. See y'all Tuesday.